So I have problem 7, which to find the shortest path from 8 to point 1724 without going inside the circle. So here I sketch out the shape that we gonna look at, and then I find out, and here is in the xy plane, and I find out the center of the circle is exactly the midpoint of the line connecting the two points A and B, because I find the equation of the line is y equal to 2x minus 10, and if we plug in the center of the circle, which is 13 and 16, we can satisfy this equation, which means the center of the circle is on the line. So I will find the distance between O and A by just a normal distance equation. Is the square root of y of A minus y of O plus a squared plus the x of A minus x of O squared. So I got 8, 4, and 8 squared plus 4 squared is 80. Square root of that is 4 square root of 5. And from here I can find AH, because here, as in the picture, AH is the tangent line of the circle. So we can use Pythagorean to find AH, which is OA squared is 80 minus the radius squared, which is 20. So AH would be square root of 60 is 2 square root of 15. So here, from here, we already find the two tangent lines. So what leaves us is this curve over here. Basically, the shortest path is gonna be the two tangent line, the sum of two tangent line, and the length of this curve. So we find out that this is the right triangle with length square root of 80, square root of 60, and square root of 20. So we just need to take the arc sine. We need to find this angle, which is equal to this angle over here. The arc sine of square root of 60 over the square root of 80, which is the arc sine of square root of 3 over 4, which is arc sine of square root of 3 over 2, which make this angle is pi over 3, which is a 60 degree angle. And also this angle would clearly equal to this angle because of the symmetry. So this angle that of the curve that we're looking for is also pi over 3. So this makes that the length of this curve will be 1/6 of the circumference of the whole circle. So the perimeter of the circle is 2r pi, and then I want to find the length of this curve. I divide that by 6. 2 times square root of 20 is 4 square root of 5, because 20 is 4 times 5. So I just take the 4 out of square root, which should become 2. 2 times 2 is 4, and then divided by 6, and then I simplify is 2 square root of 5 divided by 3. So this, which make our path that we're looking for, would be this, the length of this curve over here, plus the length of HA, which is the tangent line, times 2, because there are two tangent lines, which is 2 square root of 15 times 2 would be 4 square root of 15, and plus the length of the curve.